I come your way once again with additional mathematics. My name is Nana Yawedu and you can call me Senena. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all the videos on time. In our previous lesson, we have considered the domain of a function using a very real example of a game that you yourself might probably prepare in the future. The countries Ghana, Burkina Faso, South Africa could represent the domain of a function, right, of your game, where you are able to ask them questions on what are their capitals, and those capitals will represent the range. So in this lesson, we want to look at the range of a function, and we want to consider all the images of the domain of a function. Now, what is a proper definition for the range of a function? So when we talk about the range of a function, what we are talking about is basically looking at all these values here, right? That maps exactly to the element or an element in the domain of a function. So for instance, when we coded these with countries, all the capitals whose countries can be found in the domain will represent the range of the function, right? So we can have a codomain that consists of all other capitals, but the range will be the specific capitals whose countries we have in the domain, right? So the range of a function we say is a set of all functional images, right, or functional values of the elements in the domain. So for instance, if I have a function f of s, which I can say is equal to y, is equal to 2s plus 2, and I'm trying to find the range of f of 2, then it implies that y will be equal to 2 multiplying 2 plus 2. And it means that y is equal to 6. So the y value I've gotten here is 6. So the y here represents the range of my function because it is the image of the 2, which is the domain in the function y is equal to 2x plus 2, right? So when we take a polynomial function, for instance, what will be the range of a polynomial function? So every polynomial function, if we have, let's say, y is equal to 2x squared plus 2s plus 1, all values of x we put in that belongs to the real number system will give us values in the real number system, right? And we can have only one value here. So we say that for the range of the function, the range of this polynomial function or all types of polynomial functions will be y such that y is a member of the real number system, right? So y is such that y is a member of the real number system. Now, how about if you are looking at rational functions? So for rational functions, we can have a general range of the function. Depending on the function, we can find the range. So let's look at an instance where we have y is equal to 3x minus 1 all over x minus 2, right? So all we need to do is that we want to make s the subject in this function, because when we make the s the subject, we get the image, which is the y, right? So it means that we are going to have y multiplying x minus 2 to be equal to 3x minus 1, right? So we have yx minus 2y is equal to 3x minus 1, right? And to make s a subject, you can move all the x to one side. So we have y of x minus 3x is equal to negative 1. When this moves, it becomes plus 2y. Then we factorize our x out. So we have x gives us y minus 3 is equal to negative 1 plus 2y. Then we divide both sides by y minus 3. Divide this side by y minus 3. Then, right, it means that we have our x value to be equal to negative 1 plus 2y all over y minus 3. So in the same way, we want to find the range of the function. So now we are doing it in terms of y. And as I said, if y here is 3, it means that the function will become what? Undefined. So we must take this y now, right, minus 3 and equate to 0. Then we have y to be equal to 3. Then we'll write our range, that our range is equal to y is such that y is a member of all real numbers except y is not equal to 3. Because when y is 3, the range of the function here becomes undefined, right, as we looked at in the domain. So we should be able to move the terms, right? We cross multiply, then we make s the subject. Then once we make s the subject, we'll be able to determine the range by picking the denominator and equating to 0, so that we can add the exception, right? Y is not equal to 3. Now, how about if you have radical functions? So we can have a radical function y which is equal to the square root of x minus 2, right? So we just want to make s the subject in the same way. So all we need to do is to square both sides. So we square the square root here, and then we square the y. So it means we have y squared to be equal to x minus 2, right? And that implies that we can decide that we will make s a subject, right? So it means that we can have our x value, right? So x to be equal to y squared. When this moves, it becomes plus 2, right? So it means that for this, all the range of the values will be in the real number system, right? Y squared plus 2 without any square root on it means that the range, right, you can see the range will be equal to y such that y is a member of the real number system. So all we need to do is to ensure that we make s the subject in the relation so that we can determine the value of the range, right? So once we have s to be a linear function or a polynomial function, basically, we know that for a linear or polynomial function, the range is a member of all real numbers. How about with logarithmic functions? We know that for domains of logarithmic functions, it is members that are greater than or equal to 0. But when we find log of x for every logarithmic function, we will get members of the real number system. So it could be negative, it could be positive whole numbers, it could be decimals, right? So we say that for the range of logarithmic functions, irrespective of the functions, is y such that y is a member of the real number system, right? So that is for logarithmic functions, right? So this represents a range for logarithmic functions. So in this lesson, we have basically considered how we can determine the range of some functions, right? So we've considered how we can determine the range of polynomial functions. We've looked at rational functions. We've also considered radical functions. And we've looked at logarithmic functions. And we mentioned that the range of values are all the images that we can find from the domain of a function. Remember to like this video and especially subscribe to my YouTube channel. See you in the next lesson.